Okay, so today we are working on CC1 1.2.1 review and preview. We are on problem 146. Okay, we are matching each of the following descriptions of pennies with its possible numeric expression and then calculating the value of each expression. So the ones I have to choose from are 8 times 12 plus 7. Number 2 is 6 times 20 plus 5. 3 is 11 times 10 plus 7. And 4 is 9 times 12 plus 5. So if I look at the description of part A, it's 11 piles of 10 pennies with 7 leftover pennies. And it matches to number what? If I'm looking, I know it has to have 7 leftover pennies, which only leaves number 3 and number 1. But then it's 11 piles of 10 pennies, so it can't be number 1, it has to be number 3. Okay, part B, a rectangular array of pennies that is 9 pennies long and 10 pennies wide with 5 leftover pennies. Well, number 2 and number 4 have 5 leftover pennies, but only one of them has 9 pennies long and 12 pennies wide. It has to be number 4. Okay, part C, 8 stacks of 12 pennies with 7 leftover pennies. We already know number 1 has 7 leftover pennies. I just have to make sure there are 8 stacks of 12 pennies. And there are 8 groups of 12. So part C matches to number 1. Part D, that leaves us with, we have 1, 3, and 4. That means it has to be 2. But to double check it, a rectangular array of pennies that is 6 pennies wide and 20 pennies long with 5 leftover pennies. Number 2 does have 5 leftover pennies. And it's 6 groups of 20, okay, which does match part D. Now, I need to calculate the value of each expression. I can do this using memory with multiplication facts, or if I'm not sure of my multiplication facts, I can always multiply them out, okay? For those of us that aren't sure, I am going to be multiplying them out. So we'll just start with number 1. 8 times 12. Order of operations says that I have to do multiplication first. I'm going to do 12 times 8, or 8 times 12. 8 times 2 is 16. 8 times 1 is 8, plus 1 is 9. It's 96. And then I have to add 7. 7 plus... When we're adding, remember that we have to line up our place values. So 6 plus 7 is 13. 9 plus 1 is 10. Number 1 is 103. And I'm going to write that. I'm going to write all my answers next to the number matching the description. Okay, number 2, 6 times 20. So 20 times 6. Okay. 6 times 0 is 0. 6 times 2 is 12. 120 plus 5 is 125. So number 2 was 125. Number 3, 11 times 10. Now the trick for 10, when I'm multiplying by tens, is I can just, it's 11 and then I add a 0 at the end of it. So it's 110 plus 7, which is 117. And finally, number 4, 9 times 12. 9 times 2 is 18. Carry the 1. 9 times 1 is 9, plus 1 is 10. And then I'm adding 5, so it's 108 plus 5. 5 plus 8 is 13. 0 plus 1 is 1. 5 plus 1, or 1 plus 0 is 1. So it's 113. Okay, moving on to problem number 47. We are writing one whole number or one fraction in each blank to make each statement true. Okay, so it can be a whole number or a fraction. So 100 pennies equals, how many? What is 100 pennies? It's one whole dollar. 200 pennies equals blank dollars. Well, if 100 pennies equals $1 and I'm doubling it, it equals $2. 50 pennies equals blank dollars. Well, 50 pennies is half of $1, 50 cents. So 1/2. 10 pennies equals blank dollars. Now, I could think of this in different ways. I could say, well, it's 10. I know $1 is 100 pennies. So I could write 10 over 100. I could simplify that, but 10 over 100 will work. 1 penny equals blank dollars. Well, it's 1 out of 100. Okay, this 1/2 here would also be 50 out of 100, which is half. Okay, moving to problem 48. Matthew's mother asked him to go to the store for her. To get to the store, he walked 7 city blocks. He caught the bus and rode 13 blocks. He got off and walked 1.5 blocks to the store. He purchased the items his mother wanted and returned home the same way. We want to know how many total blocks did he travel. So if I'm looking for the total there and back, I do have to figure out, well, how many blocks did he take to get there? Well, he walked 7 blocks. He rode 13 blocks, and he walked 1.5 blocks. I'm going to add those up. So to make it easier for myself, since I have a half, I like to add in a decimal point and put zeros where I don't have the numbers, because the numbers don't change. This top number is still 7. The second one's still 13, and the bottom one's still 1.5. And then I'm going to add. So 0 plus 0 plus 5 is 5. 7 plus 3 is 10, plus 1 is 11. Carry my 1. 1 plus 0 plus 1 plus 0 is 2. That's just there to the store. If I'm going to do there and back, I have to double this number. To do that, I can add it to itself, or I can multiply by 2. I should get the same answer. We'll do it both ways. So 5 plus 5 is 10. Carry my 1. I'm going to drop my decimal point down. 1 plus 1 plus 1 is 3. 2 plus 2 is 4. He walked 43 blocks. Now I could multiply. We haven't quite learned yet in class how to multiply by decimals. So we will do it, and I will walk you through it, and we will talk more about it in class later. So 2 times 5 is 10. Carry my 1. 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4. Okay, so you notice I just multiplied like normal. What I'm going to do is I'm going to notice that, hey, I have one number to the right of the decimal, which means I'm going to move my decimal 1 place over. 43. They're the same answer. He traveled 43 blocks. Okay, moving to problem number 49. Which numbers make these division problems correct? We need to replace each box and triangle with a single digit number. Now, these can be harder to think about for some of us. So what we need to think about, okay, well, 6 times 1 is 6, right? I know below here, whatever this number in the square is, 6 only went into it 1 time. And I don't know what the leftover was, but I know that I dropped down this 2. And then 6 times 2 is 12, and that should get me 0. So really I'm trying to figure out, well, what is this number here to get me to 0? Well, it has to be 1, right? 1 minus 1 is 0. So if I go up to this top one, something, when I subtract 6 by it, is 1. Okay, I could think of it in opposite. 6 plus 1, right? If I'm subtracting and I'm getting a remainder of 1, so 6 plus 1 should get me my answer. It's 72. Now, the second one, 4 doesn't go into 2 at all, so that's why it's blank. There really should be a 0 here. Okay, but 4 times 5 is 20. Okay, so whatever this number is, 4 goes into this number 5 times. Okay, and we don't know what this number is. And 4 does go into 8, right? So if I had 8 left over, 4 would go into that evenly. So knowing that, this has to be a 0, because 20 minus 20 is 0. I drop down my 8. 4 times 2 is 8, and then I'm left with 0. Last problem, number 50. So a line segment is a piece of a straight line, okay? On our paper, we are going to draw 2 line segments that are the same length and each about as long as your pen, okay? So part A, draw a line segment that is as long as a pen. Then draw marks on the line segment to show how you can divide it into 8 equal lengths. So I'm going to draw a line, and I have to separate it into 8 equal lengths. Well, there's 2, 3, 4, 5, 6, 7, 8. 8 equal lengths. Part B asks me to draw another line segment. Now I have to divide it into 5 equal lengths. So I have to think about this a little bit more. I can't just divide it in halves like I did in the last one, because it's 5. It's not an even number. So, and I might have trial and error. I might have to erase it. So there's 2, 3, 4, 5. Now that's not equal, right? So I'm going to actually, on my end, erase part of my line. To make it equal, because now it's equal. So part C, was it easier to divide a line segment into 8 equal lengths or 5 equal lengths, and why? I'm going to let you answer that. So I know which one was easier for me. I just want to know why. Which one is easier for you and why? As always, if you have questions about any of your homework, please don't hesitate to come in and talk to me. Thank you.